Welcome to this video on using Gibbs free energy to find temperature ranges for feasibility. The basic question we're asking here is which temperatures will a reaction be feasible for? So the kind of question that this pertains to is asking this sort of question. So for what range of temperatures will steam condensation be feasible? Or in other words, what we're asking here is for which range of temperatures will delta G be less than 0, and our relationship that we're going to be using is this Gibbs relationship. Delta G is delta H minus T delta S, and if you don't know anything about that relationship, you're better off watching the previous video in order to help you to understand it. So there are, broadly speaking, two methods that we can go about here. Method one I'm going to call intuition. And this is the method to go for if you don't really particularly like inequality signs, because method 2 is going to be based on an inequality. Two methods. So first method 1, intuition. So the condition for feasibility is delta G is less than 0. So when the sort of tipping point, so there's going to be a tipping point for feasible or not feasible occurs at temperature when delta G is equal to 0, equals 0. So it's an inequality here, and I'm going to call it TC for critical temperature, where that tipping point is going to occur. And so we want to try and find out what TC is. And so what we're going to do is we're going to substitute in the values into the equation, the formula that we've got up here. So we know that delta G should be equal to 0. Delta H is going to be minus 44 kilojoules per mole. And then we're going to subtract this temperature TC, which remember will come out in Kelvin, and that is going to be multiplied by delta S, which we're going to turn into kilojoules per Kelvin per mole by dividing by 1,000. That bracket looking clear. Okay, so then we just need to solve this to find TC. So we're going to add this term to both sides and then divide both sides by what's multiplying TC, and we're going to get minus 44 divide by, if I do the divide by 1,000, minus 0.1188 kilojoules per Kelvin per mole. And when I stick that in, I'm going to find here that my TC value comes out at 370 Kelvin, at least to 3 significant figures. And if I look at my numbers here, I've got 3 sig figs and 4. Because I'm doing a division, I conserve significant figures, so I get my critical temperature value to be 370 Kelvin. And so then I'm going to use by which I mean think. So what we want to try and do is understand, is it feasible below 370 or above 370? And the way I think that the easiest way to think about it is to think about what will delta G be less than 0 at a temperature of 0 Kelvin. So if the temperature is 0 Kelvin, will delta G be less than 0? So if we look at this formula, we've got minus 44 in there, and then we've got minus T times minus 0.1188. Now if the temperature is 0, then all this term here just disappears. So I'm left with delta G is minus 44 kilojoules per mole, so the answer here is yes, it will be. And so that means it's feasible at 0 Kelvin if 370 is the tipping point, and that must mean that so the range for feasibility is a temperature of less than 370 Kelvin. Now, it's feasible at 0, it changes feasibility status at 370, so therefore it must be the less than 370. Second method is just using the inequality directly. So we say here that we need delta G less than 0 for feasibility. And so what we do is we just stick the numbers into the formula. So minus 44 delta H minus the temperature T times the entropy change, which is minus 0.1188. And that's got to be less than 0. So now you've got to just be extra careful with these inequality signs. And at this point, I would suggest that we multiply through our minus signs. So we're going to have minus 44, and then this is minus t times a minus number becomes plus t times 0.1188. It's got to be less than 0. Now that is actually really helpful because this has become positive. Now remember, with inequalities, you have to flip the inequality sign if you multiply or divide by a negative number. Now that's actually quite annoying to have to remember, so I just make a rule for myself, which is I never divide by a negative if I can avoid it. So if I add minus 44 to both sides, if I add 44 to both sides, I get rid of this, and I end up with t times 0.1188 is less than 44, and therefore when I divide through this time by a positive number, I get T is less than 370 Kelvin to 3SF, and that way I've done it all in one step. So the intuition method or the inequality method leaves us with the same range. Now one final thing just before we leave this to mention to you that T is always positive. Remember, it's in Kelvin, so we can't get negative temperatures. If you're getting a negative number out of this, something has gone wrong, so check your working.